In our fifth and final example, we need to find the values of the third, fourth, fifth, and sixth terms of the sequence, having been given the value of the first term equaling 1, the second term equaling 5, and a framework sequence of 3 times the value of 1 step back, the previous step, plus 2 steps back, 2 terms back from what step we're currently on. All right, let's see how we're going to get this started. So our framework of the sequence is 3 times the value of 1 step back in the sequence, plus the value of 2 steps back in the sequence. So this is pretty different from what we've been doing. And it is because I need these 2 different term values that we are given the first 2 term values of this sequence. So the first term, a sub 1, has a value of 1. Great. And the second term, a sub 2, has a value of 5. So let's write our framework for these 4 steps that we are being asked to determine. So we have 3 times the value of 1 step back plus 2 steps back for all 4 of these options. So this opens the door of conversation that, truthfully, a sequence has an infinite number of terms. We're just asked for some specifics. And as a result, you could be asked for any number of those terms and be given any number of those terms. Here we go. So remembering that a variable and a number side by side, this a and its coefficient 3 are multiplying. So I'll put a dot to help our brain remember we're multiplying. And there is no coefficient in front of my second term. All right. So the value of 1 step back is 5. It's right there. And the value of 2 steps back, so 1, 2, is 1. All right? So this is 3 times 5 order of operations, which is 15, plus 1, making 16. For our fourth term, we start with 3 times the value of 1 step back. So that's the 16. Plus the value of 2 steps back. So 1, 2. That's the 5. Order of operations. 3 times 16 is 48. Plus 5. 48 plus 5 is 53. In the fifth term, we start with 3 times the value of 1 step back. Well, that was 53. Plus the value of 2 steps back. So 1, 2 steps back, which was 16. Order of operations. 3 times 53 is 159. Plus that's 16, which makes a value of 175. On the 6th step, we see 3 times the value of 1 step back. So 1 step back had a value of 175 plus the value of 2 steps back. So 1, 2. That was 53. Order of operations. 3 times 175 is 525 plus the 53, which as a result has a final value of 578. So this problem was very different in that it was much more involved, and we had to look at 2 previous steps, and we had a coefficient in front of one of our terms. So the process of just going through the framework is still very much the same. but we had just more framework to process through. And because the problem asked for all 4 of these values, we would have to give them all, which is not hard, not bad at all. And there you go.